This target is using a real reusable Unreal Engine 5.5 C++ health component. It begins at 100 health, receives 40 damage and changes to 60, then receives 60 more, reaches 0, and enters a depleted state. The three-dimensional health bar, body color, label, and runtime logs all agree. In this lesson, we will build the actor component, bind Unreal's AnyDamage delegate, clamp the state safely, broadcast health changes, keep visuals decoupled, and test the exact 100 to 60 to 0 path. UHealthComponent derives from UActorComponent and is marked blueprint spawnable. It owns max health, current health, the damage binding, and 2 public delegates. It does not own a mesh, health bar, animation, or user interface. Primary component tick is disabled because health changes only when an event arrives. This makes the component inexpensive and reusable. A player, enemy, destructible prop, or objective can attach the same state logic while choosing completely different visual reactions. During begin play, current health resets to max health. The component gets its owner and binds handle any damage to the owner's OnTakeAnyDamage delegate with add dynamic. The demonstration driver later calls UGameplayStatics ApplyDamage. Unreal routes that call through the target actor, then broadcasts the AnyDamage event with the amount, causer, instigator, and damage type. The component listens without requiring the target class to forward a custom function. The calculation first clamps current health into the valid 0 to max range. If damage is 0 or negative, it returns the safe current value, so a damage event cannot accidentally heal the actor. Positive damage subtracts once, then fmath clamp prevents the result from falling below 0 or exceeding max health. This pure helper is easy to test. 100 minus 40 becomes 60, 60 minus 60 becomes 0, and 200 damage against 20 health still stops at 0. When the value actually changes, OnHealthChanged broadcasts current health, max health, and the delta. If the result reaches 0, OnHealthDepleted broadcasts once for the terminal state. The target actor listens to these delegates and updates its visual presentation. A user interface, sound system, enemy controller, score manager, or analytics listener could subscribe independently. The health component remains a small source of truth instead of becoming a dependency hub. The target converts current health divided by max health into a 0 to 1 ratio. That ratio scales the fill bar. Full health use is green. Damaged health use is amber. 0 health use is red, clears the fill, changes the label to depleted, and tilts the body. These are presentation choices owned by the target actor. The component only broadcasts facts. Keeping that boundary lets the same health logic drive a boss bar, a minimal HUD, a skeletal animation, or no visuals at all. These are 3 real frames from the saved health component map. At 100 health, the target and bar are green. After 40 damage, the label reads 60 health, the bar shrinks, and the target turns amber. After 60 more damage, the bar reaches 0, the target turns red, tilts over, and the label reads depleted. The fixed camera and pedestal make every difference auditable. This is the real compiled ApplyDamage path, not a manually recolored mockup. The runtime log records the owner, 100 to 60 after 40 damage, 60 to 0 after 60 damage, the depleted event, and final health 0. Unreal Automation separately verifies the default maximum, no component tick, both exact transitions, excess damage clamping, negative damage rejection, and current health clamping. The test passed with 1 success and 0 failures. Real visuals, the engine damage trace, and the pure calculation test all support the same result. The reusable pattern is 4 steps. Listen to the owner's engine event. Clamp 1 authoritative state transition. Broadcast a small set of facts. Let outside systems react through their own presentation and gameplay rules. Avoid tick when an event already describes the change, and keep the calculation pure enough to test without a running world. This architecture scales naturally to shields, stamina, energy, durability, and any other bounded resource.